All right, today we're diving into what is arguably the next huge leap in AI, agentic systems. Now, these are not your everyday chatbots or image generators. We're talking about AI that can actually do things in the digital world. But when you give AI that kind of power, it raises a massive question. How on earth do we keep it safe and secure?
So here's the game plan. First, we'll pin down what Agentic AI actually is. Then we're going to peek inside the agent's mind to see what makes it tick. We'll climb what I'm calling the Autonomy Ladder to understand the different levels of risk. After that, we'll get into the new kinds of security threats that pop up and, most importantly, how we can build digital guardrails to protect against them. And finally, we'll wrap up by thinking about the future of control in a world full of these systems.
Okay, first things first. What really sets this kind of AI apart? Well, it all comes down to a huge shift from just generating stuff, like text or pictures, to actually taking action and getting things done. I mean, think about it. We're all used to chatbots that respond to a prompt, right? But Agentic AI is totally different. It's designed to achieve a goal. That means it can interact with software, it can manage your files, it could even, carry out financial transactions for you. It's a doer, not just a talker.
So here's the key takeaway. Agentic AI isn't just one thing. It's a whole system. It's not just a language model floating in the cloud. It's a model that's been given a specific role, a set of tools to work with, and a memory so it can learn. You put all that together and you get something that can tackle complex jobs all by itself.
So, let's pop the hood and take a look at the core parts that give these agents their power to get stuff done. You can basically break an agent down into 5 key pieces. At the heart of it all is the large language model. That's the brain doing all the thinking and reasoning. Then you have its tools. Think of these as its hands and eyes, letting it do things like write code or search the web. The instructions are its job description, telling it what it's supposed to do. Memory lets it remember past conversations and learn. And finally, protocols are just a standard language it uses to talk to other systems.
And these agents can be set up in a couple of different ways. You've got your single agent system, which is kind of like a lone wolf, one AI handling every part of a task. But then you've got multi-agent systems, which are way more like a team of specialists. You might have one agent that's a researcher, another that's a coder, and a third that's an orchestrator, all working together to solve a much bigger problem.
Now, this is really important. Not all agents have the same amount of freedom. Their ability to act on their own exists on a spectrum, and understanding this scale is absolutely critical for getting a handle on the risks.
So at the very bottom of the ladder, you've got level 0. This is super simple, a one-for-one transaction. Like an app that can identify a flower from a picture you take. You give it one input, the photo, and you get one direct output, the name of the flower. It's totally straightforward and predictable. Okay, moving one step up to level 1. Here, the system can follow a pre-programmed sequence of steps, kind of like a simple assembly line. For instance, the system could be set up to get an email, find the attachment, save it to a folder, and then send you a confirmation. The path is totally fixed, it never, ever changes. At level 2, things get a little smarter. Here you have an orchestrator agent that's basically a project manager. It can look at a request and pick the best path forward from a list of predefined options. So if you ask it to book a trip, it can decide whether to use the flight-only workflow or the flight plus hotel workflow, all based on what you asked for.
And finally, at the very top, we hit level 3, full autonomy. This agent doesn't need a map because it draws its own. It can reason, plan, and string together totally new actions to solve problems it's never seen before. You could tell it to plan a successful product launch, and it might go off and research competitors, write marketing emails, and schedule social media posts, all by itself. The potential here is just staggering, but this is also where the security risks become truly unpredictable.
Right, so as these agents get more and more autonomous, they create a whole new world of vulnerabilities, problems that our traditional cybersecurity playbook just wasn't written for. And the threats are pretty sophisticated. We're talking about things like memory poisoning, where an attacker slowly feeds an agent bad information, or tool misuse, tricking it into using its abilities for malicious reasons. An attacker could even manipulate its goals with a clever prompt, spoof its identity, or just flood the human supervisor with so many alerts that something critical gets missed.
So how do we fight back against this stuff? Well, one of the leading methods experts are using is called taint tracing. You can think of it like a detective following a trail of muddy footprints. It's a security technique designed to track any untrusted data, like a user's prompt, as it moves through the entire system.
Here's the core idea. The second any untrusted data enters the system, it gets marked, or tainted. Then, every single component that data touches, whether it's a tool, a memory file, whatever, it also gets marked as tainted. This creates a crystal-clear audit trail, showing security teams exactly where a potential attack is spreading so they can isolate it and stop the damage.
So, we know the risks are real. How do we actually build these incredibly powerful systems in a way that's safe? Well, the answer is you have to build security in from the very beginning, from the first sketch on the whiteboard all the way to deployment.
Right. Security can't just be something you bolt on at the end. It has to be part of the foundation. And according to experts like the Cloud Security Alliance, that means thinking about security across the entire lifecycle of an AI system.
So in the planning and design stage, you're already modeling threats and mapping out risks. During development, you apply what's called the principle of least privilege, which just means you only give an agent the absolute minimum permissions it needs to do its job. At deployment, you hammer it with intense security testing, including AI red teaming. And once it's live, you have nonstop monitoring and, of course, human oversight.
And this right here might be the single most important guardrail. No matter how smart or autonomous the system gets, if it's about to do something irreversible, like, say, delete a critical database or send a large amount of money, a human being has to be in the loop to give that final thumbs up. It's the ultimate safety net. So, what does this all mean for our future? Well, as these agents become more and more woven into the fabric of our digital lives, our ability to build systems that we can genuinely trust becomes absolutely paramount.
At the end of the day, the goal here isn't to hold back the potential of agentic AI. It's to unlock it responsibly. By embedding security and human oversight deep into their design from day one, we can create incredibly powerful partners that work with us safely and effectively.
And that leaves us with the one massive question that we will all need to grapple with as this technology continues to race forward. It's a question that goes way beyond code. It's about policy, ethics, and how we want to define our future partnership with artificial intelligence.